AMC 8, 2026, starting with problem 1. So in this problem, we can group 3 numbers at a time, and we can add those 3 numbers up. And we get 0, 3, 6, and 9. A pattern forms. Now we add these 4 numbers up, and we get 3 plus 6 plus 9. That's 18. The answer is A. Moving on to problem 2, we find the sum. 5, 5, 5, 5. 5 times 4, 20. That's the sum of all the ones. And then we're going to put the 2's in even groups. And we have 6 times 4 groups is equal to 24. And finally, we have 3 times 3 is equal to 9. We add all of this up. We have 44 plus 9. That's 53. C. Problem 3. So he has a wire 24 centimeters long. He's trying to create these shapes. So let's see if he can. Regular hexagon, 6 sides. Each side is 5 centimeters. So he needs a wire 30 centimeters long to create it. And sadly, he does not have that. So next, a square of 36 area. So if the square has an area of 36, that means each side is a side length of 6. And there are 4 sides. So that means he needs a wire 24 centimeters long, and he does have that, so it will work. Right triangle whose legs are 6 and 8, so that means 6 plus 8, that's part of the perimeter. Now we need to find the hypotenuse. The hypotenuse is 10, is 6, 8, 10, and we have 24 centimeters as the necessary length of the wire, and he does have that as well. So he can make the square and the right triangle. So the answer would be D. Problem 4. So we can set his original savings as S, and his original savings decreased by 20% in July. So that means he has 4/5 of his original savings, and then it increased by 50% in August. So now he has 3/2 times more than the amount he had in July. So we multiply that. And it's asking the percent amount of his original amount. And we can multiply. Now he has 6/5 S, or 120% of his savings account. So the answer is E. Obviously, you don't have to convert it to fractions, but fractions are easier. Problem 5. So we see that the total trip is 100 miles, and if she was at a speed of 40 miles per hour, that means she took 100/40 hours. And we can simplify that, and we get 2.5 hours, and total trip was 3 hours. So we're trying to find her lunch break. So that means her lunch break was 0.5 hours, or 30 minutes long. B. Problem 6. So we first calculate the area he can't reach with borders of 1 on each side. We know that the length is 8 and 6. So we find the area of the area he can't reach, and that's 48. Total area is 80. 8 times 10. So we have 80 minus 48. 32 is the area that he can reach, which is the shaded region and the outside edge or outside perimeter. So we have 32 over 80, the total area of the field, and we have 2/5 if we simplify that. So the answer is E. Problem 7. So we're trying to find how far this electric bike can go on a fully charged battery. So 40 miles gone so far, and 1/2 plus 3/10 is the total amount of battery power used. That total is 4/5. Let's set the fully charged battery as X. So we only use 4/5 of the fully charged battery to go 40 miles. Now, how to find X? We just multiply 5/4 on the left side, and we get 50. So 50 is the total distance the fully charged bike can go. So the answer is C. Problem 8. So 74% answered yes. We're trying to find the fewest number of people who answered the question. So 74 over 100. Let's see if we can simplify this fraction. So this is 74%. 74 over 100 is 74%. We answered yes. But let's try to simplify this fraction. So 37 over 50. That's the most simplified it can get. So 50 people total, 37 answered yes. Same as 74% that answered yes. So the answer is D. Problem 9. So we can just solve. Square root of 81 is 9 times 16. The square root of that. So that's just 3 times 4. That's 12. And then we have the square root of 81 times the square root of 16, which is just 4. And the square root of 81 times 4 is just 9 times 2. So that's 12 over 18. Now we have to simplify, so it's just 2 over 3. The answer is B. Problem 10. So we have Olympia, who finished 2 minutes ahead of Melina and 3 minutes behind Pedro. So Pedro is up here. 3 minutes behind Pedro. Now it says Olympia finished 6 minutes ahead of Luke, so that means Luke finished 4 minutes behind Melina. And then Nico finished 11 minutes behind Pedro. So that means Nico finished 2 minutes behind Luke. So it's asking who finished in fourth. Pedro finished in first. Olympia finished in second. Melina finished in third. And then Luke finished in fourth. So the answer is A. Problem 11. So we're trying to find the length of the curve. Radius 5. So that means the total circumference is 10 pi. And we have a fourth of it. So we have 10 pi over 4. We have 6 pi over 4, looking at the second quarter circle. And then we continue. So we have 4 pi over 4. We have 2 pi over 4 and 2 pi over 4. We add all this up and we get 24 pi over 4, and that is 6 pi. Problem number 12. So we're trying to find the digit in the top circle. So the digit can be 1, 2, 3, 4, 5, or 6. But we can eliminate 1 and 2 immediately, because if 1 was right here, that means 8 would have to be in the other circle, and that won't work because 8 is not one of the digits from 1 to 6. Same goes for 2, and we can eliminate 6 as well, because if 6 is here, that means it would have to be 0 in the next circle. That would not work either. Now we can test 3. So if 3 was right here, 6 would be right here, and 3 would be right here because the middle number is 6. So 6 is the sum of 3 plus 3. And we can't do that because 3 is used twice, and there can only be each digit is only used once. So we can eliminate the answer choice 3. Now it's between 4 and 5. We just tested 2 scenarios. So 4, 5, 2. That means 2 would have to be used here as well. That won't work because 2 is again used twice. Okay, so the only logical answer would be 5, or the only answer that would work would be 5. And we have to make sure if this is truly the case, because one of the answers, as you see down here, it is impossible to fill the circles. Okay, let's test it. 1, 3, 2, 6, and 4. And it works. So we have each of the digits that are used exactly once, and none of the digits are besides 1 to 6. So the answer is 5D. Problem 13. So as you see here, we can draw a larger square around the slanted square, and we have a side length of 1, side length of 3 for the triangle. So that means the area is 3 over 2. And each of the triangles are the same, so we multiply by 4. The area of the triangles is 6. So we want to find the area of the larger square now. So we can subtract the area of the triangles to find the slanted area. So we know that the side length of the square is 4, so that means the area is 16. 16 minus 6 is equal to 10. That is the area of the slanted square. A. Problem 14. So as you see here, we can set the first integer on the left as x because it is the smallest integer. Because they are equally spaced, we know that the second integer is x plus y and the third integer is x plus 2y. Now we have equations because the sum of the first and second numbers is 40. So 2x plus y is equal to 40. And the sum of the second and third numbers is 60. So that means 2x plus 3y is equal to 60. That means y is equal to 2y is equal to 20, y is equal to 10. Now it's asking for the sum of all three numbers. Well, we have to first find x, and we plug into the first equation. So 40 minus 10 is equal to 30. Divided by 2, 15. X is equal to 15. That means y is equal to 25. And x plus 2y is equal to 35. So we add all three numbers up, we get 75. Problem 15. The best way to solve this problem is to test scenarios. And after you test a couple of times, you'll realize that the most optimal way to place these cubes is to place them in a 2x2 stack. And obviously the image won't be too great, but it will work for this problem. Okay, so as you see here, in cube 1, the gray face will be right here on the top, and the gray face will be on the right. And in cube 2, it'd be on the left and on the top. Cube 3, it will be on the bottom and on the left. And cube 4, it will be on the right and bottom. And as you see, each of the cubes are touching faces, gray faces, with two other cubes. And this maximizes the amount of cubes used. And as you see, it does fit every requirement that is in the problem. So the answer is 4A. Now we're going to move on to problem 16. So as you see here, we're looking at 4-digit integers consisting of only even digits, and we're seeing if they're divisible by 4 or not. So we don't have to look at or pay attention to the first two digits because the last two digits prove if the number is truly divisible by 4. Okay, so we can start using casework. 0, 0, 0, 4, 0, 8 are all integers that are divisible by 4. And we can continue. We have 2, 0, 2, 4, 2, 8. And as you see, we have this repeating sequence of where the ones digit is always 0, 4, 8. So that helps us find the total number of numbers. So we have three types of units digits for each of the tens digits, and there are 5 tens digit because we are only using even digits. So 15 total numbers that are divisible by 4. So let's count how many 2-digit numbers are consisting of only even digits. So we have 5 times 5 because there are 5 even digits for both the tens digit and ones digit. So 25 total numbers. So 15 over 25 is equal to 3 over 5, and that is your answer. Problem 17. So you have to realize that there are two types of people. There are two types of people, A and B. Type A is sitting next to one person only, and type B is sitting next to two people. This will help us in the casework that follows. So we can label the people 1, 2, 3, 4, and this will help us determine how many arrangements are possible. So if person A starts or person 1 starts, that means person 3 or 4 has to come in the next seat. So 3 or 4. Now 3 won't work. The reason why is because, for example, let's just say the sequence is 1, 3. It starts with 1, 3. So that means in the next following chair, the third chair, it will have to store 2 or 4 because 1 and 3 is already used. So 2 or 4. However, 3 sits next to 2 and 4, so that won't work. So the only solution would be 1 sitting next to 4. 1 sitting next to 4. And then in the third seat, that means the third seat will have to store 2, and the final seat would have to store 3. However, that won't work either because 2 and 3 are sat next to each other. So that means type B has to start. Type B has to start. So let's just say person 2 will start. We'll start the row. So in chair 1, there will be person 2, and that means in the second chair will have person 4 because person B sat next to A and B already in the previous arrangement. Okay, so we have person 4 in the second chair. That means person 1 has to be in the third chair. This person 4 cannot be next to person 3. And finally, person 3 is in the final seat. And that does work. That arrangement does work. Now, this is the only arrangement that works for number 2, for a arrangement that starts with number 2. Now we are gonna have the arrangement that starts with number 3, and this will just be the second arrangement. So 3, that means person 1 will have to come second, and person 4 will have to come after that, and then person 2. So there are 2 arrangements that work. And obviously, an arrangement that starts with 4 won't work because it will be the same that happened with person 1 because they are the same type. So the total answer, 18. So we're going to do casework based on the amount of consecutive odd positive integers, starting with 2 because 2 is the bare minimum. So we have x plus 2, 2x plus 2 is equal to 60. So x is equal to 29. That works. Now let's test 3. So we have x plus 2, x plus 4. That's 3x plus 6 is equal to 60. X is equal to 18. That does not work because it has to start as an odd integer. So that does not work. Let's test 4. The reason why I'm doing this is because there aren't many cases to test. X plus 2, x plus 4 is equal to 4x plus 12 is equal to 60. So x equals 12. That doesn't work again because 12 is not odd. Okay, now let's test 5. Obviously, you don't have to write all this again. You can just add on from the last one. I'm just writing all again so it's more clear. Let's see. So 5x plus 20 is equal to 60. Now x is equal to 8. Again, it's even. That does not work. Instead of erasing this, let's just add on because there's too many now. Okay, so x plus 10 now. And that's 6x plus 30 is equal to 60. So x is equal to 5. That works. So we have 7 now. Let's see. 7 odd positive integers. We have 7x plus 7x plus 42 is equal to 60, and that gives you a fraction, so that does not work. Okay, let's move on. So it'd be x plus 14 now, so it would be 8x plus 20, 30, 42, 56. And we're almost done because the next one won't work because it will be negative. So we have 1 over 2. That would obviously be a fraction 2. So there are only 2 options or 2 integers that work. And problem 19. Without loss of generality, we can set the distance between the park and the tree as 1. So the total distance of Miguel's path and Luna's path combined together is 2, because Luna runs 5 times faster than Miguel walks. We know that Miguel's path covers a total distance of x, and we know that Luna's path covers a total distance of 5x. Adding them together, 6x is equal to 2, x is equal to 1/3. And it's asking what fraction of the distance between the entrance and the tree does Miguel cover on his own time. So it's 1/3 of the total distance between the park and the tree. So D. Problem 20. So we'll focus on order later, and now we're going to focus on finding the cases based on how many coins there are of each. So gold coins are worth 1, silver coins are worth 3, and we're trying to make 8. And as you see here, there are 3 cases. So I'm off the bat, I see 8, 0. Obviously 8 is in the x position, 0 is equal in the y position, and we have otherwise we have 5, 1, we have 2, 2. So there are 3 cases. Now we can focus on order. So if there are 8 gold coins, there is only 1 arrangement of them because they're all gold coins. They're all the same. Okay, all these gold coins are the same. So now we can focus on the second arrangement. So there's 5 gold coins and there's 1 silver coin. So the silver coin can go in 6 different places. So as you see right here, gold coin tower right here of 6 coins. And then we can pick any of these 6 coins to become the silver one. And then all the other ones are gold. So there's 6 cases. Finally, there's 2 gold coins, 2 silver coins, and there is 4 choose 2 ways of putting the gold coins first, and then whichever ones are left are put for the silver, or the silver's place. So we have 4 times 3 is 12, divided by 2 is 6. So there's 6 arrangements as well. Now we add these arrangements up, so we have 13 arrangements in total.